In this video, I am going to show you how to make a drawing, as in like a blueprint drawing. So you can still make these things in CAD. Not everything's going to go straight to a stereolithography file and get 3D printed. Sometimes you might want a drawing so you can fabricate something yourself in your shop, or give it to a machine shop, someone who knows how to make it. So I made this simple bracket right here to demonstrate that with. Now that I'm looking at it, I think I want to add just another extra feature, like a fillet. There, that's better. Yeah, fillets are... I'm not entirely sure how to design fillets, but it's my understanding that they help enhance the strength of the part at corners. So that's not just a solid corner. I think I can see how it would happen where you have a sharp corner here. Something's more likely to break at it than when you have like a continuous curve of a fillet. So, okay, I feel better now. I'll save the drawing. And now I'm going to, I said model, it's a 3D model drawing, but now let's make the actual drawing. So go over here to design, all the way down here to drawing, and you click on from design. And you see the model gets highlighted, or kind of, I don't know, I guess it's a ghost sort of thing, where you can select the contents, whether you want the full assembly, which this is basically the whole assembly, what's visible in the window, or you can select. As far as drawings, I guess you could select either to make a new drawing or add to some kind of existing one. I've never run into that situation myself yet. There are some templates you can use. I just stick with for Scratch. And the standard that you can use is either ISO or ASME, which that will depend. That depends on what kind of paper you can choose from. So ISO, it's going to give you metric paper sizes, whereas you go to ASME, it'll give you the English or imperial page sizes. I prefer ASME because that's what corresponds to my printer at home. So I'll do it on 8.5 by 11 paper, which is apparently sheet size A. And units, you can do either inches or millimeters, but since I work mainly in metric, and that's how I design this part, I'm going to leave my units at millimeters. So I'll click OK. And it's going to take a minute to get to the drawing space. You can see it's working, and Fusion 360 is doing its thing. I know right now it's blank, but eventually you'll come up with a sheet of paper. Which is going to happen at some point. Here we go. It's coming. Here we go. Now I forgot to mention that you could set this as either portrait or landscape. Let's see if I can actually adjust that up here. I don't usually mess with these settings very much. Sheet size A, 8.5 by 11. Oh, yeah, you can adjust it right here. So I have 8.5 by 11, so it's vertical, but if I select 11 by 8.5, it makes it horizontal or landscape. There we go. I feel better now. Alright. So let's create our view. We start with a base view. So I'm going to click up here with a base view. And it's asking, it's asking for a reference. So create new. Okay, that's fine. Representation, model. That's the only thing it gives you there too. I'm not entirely sure when you'd want to change that, since I've never had to mess with that before. Now appearance for orientation, it gives you choices from your basically your view cube. We have top, front, right, home. I'm going to start with just the front here. And it gives you different styles, whether you have visible edges, visible and hidden edges, shaded, or shaded with hidden edges. Typically, I do visible and hidden edges. That way, when you're looking at a drawing, you not only see the outline of your picture, but you also see where your holes are, so where they pass through relative to the view. And you'll see that once I get this all set up. And over here is your scale. So right now it's at 1:2. Which is, to me, it's a little small for what we're doing here. So we can probably adjust that. Let's see, well, if we do 1:5. Yeah, the 1:5 makes it smaller. If you make it 1:1, 1:1 means that, you know, this would be the same size as what you're actually making. Whereas 1:2 is going to be half the size. 1:5 is going to be 20% of the size. Now, if you made this 2:1, makes it twice the size of what you're making. So I think actually 1:1 might be better. I think that might be okay. Let's try 1:1. And sometimes you might want to mess with it a bit. There's down here, there's some other things here, like edge visibility. I don't think I've ever really messed with that. I think I've just left it off. Interference edges, I've left that off too. Thread edges, I haven't messed with any of these edge visibility settings. So what I'll do now is I'll just click there to place the base view, and then you see the square and you hit OK. Now from there you can do your projected views. So what you do is you click up here, projected view. It asks you to select a parent view. Well, you only have one view on the paper right here, so I'll click on that. And AutoCAD will automatically place your views. Now, I feel like there's something wrong here, because the way I was taught to do this in engineering school, isometric view, which is like your home view in your model space, where you're looking at everything at an angle, should be in the upper right hand corner of the paper. So I think I need to change where my base view is located. So I'm going to move it here, move it down here, like that. Yeah, you see the invisible lines there? That's where the holes are in my bracket. I just like to point that out there. I'll click OK. Getting a little sidetracked. Now let's try projecting the views again. So we got the front, we got a side view, got a top view, and there's our isometric view. And now that's good. So you can either press enter or click on the checkbox. I'm just going to press enter. There we go. Now, my problem with this is that my picture is a little big. So I guess 1:1 just isn't going to cut it. It's just too big. So what I'm going to do is I'm going to double click on the base view, and I'm going to make my scale 1:2. And look, it makes everything smaller. So I'm good with that. Click close. Here we go. So now we have our drawing. I'm going to click save while I'm at it so I don't lose it. And call it bracket drawing, world bracket folder. There we go. And now we're all good. So let's add some dimensions, because we want to know how big this thing is. And I'll go over some things I learned throughout my own engineering studies about dimensioning stuff. So one rule is don't duplicate dimensions. So if you already have like this here dimensioned, you don't need to dimension over here if it's the same width. So in order to dimension, it's as easy as clicking on the dimension button up here and then clicking on a line and then just setting it to wherever. It actually snaps as far as the dimension lines go. Sometimes you want it farther out if you're going to stack dimensions, which I am going to do here. So here, I'll bring this out a little bit like that. I think that'll be okay. And just click, and there, it sets it. Let's see what else needs dimensions, because another thing that the dimensions need to do is they need to convey the, basically everything you need to know about the drawing to make it into a real thing. So you need to make sure it's dimensioned. This needs a dimension right here. This line I zoomed in a little, so I'll stick that out a little bit, because I'm going to also do this lower dimension here. Oh, and another thing too is add dimensions to where, what they're telling you the size is really obvious. So I want to say how long this is, from here to here. But it's not really obvious looking at this, because you have this bit in the way and this fillet here, which isn't really conveyed. You don't really know that until you hover over here. It says 47.5 millimeters. So, yeah, and then you're like, why is it 47.5 millimeters there? That's because you can't tell there's this fillet right here. So, do it here. Click on that. And, yeah, I think that's a good place to put that measurement there. And same thing with this part right here. You can zoom in. Because that's just more obvious how big this is compared to like doing it up here. And the same thing with the height. There you go. We're making it a ways. We'll want to, let's see, where else do we want to dimension? Should probably dimension that right now. So here's another dilemma here that you might run into as you're dimensioning things. You should not have any dimension lines cross each other. Otherwise, your drawing could get really confusing. If you cross lines, they're harder to follow where the dimensions are. I'm guilty of this when I'm doing just quick drawings on a notepad. Where I can get myself easily confused, whereas when you're doing this in an Autodesk product, I feel like it's a little easier for someone to figure out when that's going to be an issue. So I'll demonstrate how to dimension a fillet. So I'll make sure I click my dimension button up here, and I'll click here, and here you go. Gives you a radius of 2.5 millimeters. And I'll put it there. There, so now we know how big that fillet is. Alright, so with that in mind, there's no really good way for me to actually dimension this here without making the lines cross. You see how those are crosses down here at the arrow. I don't like that. So I think what I'm going to end up doing is, since we know there's a fillet right there now because of this dimension, it's okay for us to actually dimension that here. Or you know what? That might not even need a dimension now. I'll tell you why. So with these dimensions, you might have to do some math too, which I'm hoping that if you're doing CAD stuff, you're already okay with doing math. So, for an example here, this whole length here is 60 millimeters, and this whole length here is 10 millimeters. And you want to know how big this side is here between this corner and the fillet. So you take 60 minus 10, you get 50. You take 50 minus 2.5, and you get 47.5. So let's see. Yeah, you see? So that's another thing too with the dimensions. Have enough dimensions that if you can figure out something mathematically, it's okay. The same thing with with this dimension right here. Now this is 50 millimeters from this corner to that corner. It's 10 millimeters here. You take 50 minus 10, it's 40. 40 minus 2.5 millimeters is 37.5. Right? Right. There we go. So there's that. So now that leaves a matter of these holes. Right? We gotta do something with the holes. So with the holes, you should have center marks and center lines going through them. So let's start off by doing center marks by clicking up here with center marks, and you select the hole, and hey, there you go. You just click on each hole and it plops a center mark in right there. And even with the hidden lines, you should have center lines like that. That way you can tell that those are hole centers. Right there. Yeah, each of those. That way you know they're holes. And you know, there's a center line to them. So there you go. There's that. And now let's add some dimensions to these holes, because we need to know where exactly these holes are going to go. So let's go back up here to dimension, and I want to know where these holes are, you know, relative to this corner. So I'll click there. I'll click there. Oops. Here we go. Yeah, if you might have to wiggle your mouse a little bit, 'cause otherwise it might give you like a dimension angle. I don't want that. So yeah. So you want it straight on. You know, it's 25 millimeters from there to there. We want to know how far the hole is from there to there. So we'll do another dimension like this. And that's why I wanted to get this 50 out a little farther, so it wouldn't interfere with my 10 millimeter dimension right there. I actually don't really like where that is. I'm going to put that on the other hole. So I'm going to click undo and try up here. See? Yeah, I guess it doesn't matter. I guess it's a little less cluttered up here, especially when you have the 25 millimeter already down here and 10 millimeter up here. You can see that the holes are aligned here based on the center marks. I think that should be okay, because you see that's 25 here and it's 10 there. Actually, just to drive it home so that you know that this is 10 millimeters here and this is 10 millimeters there, you could say that that distance is typical. No, I don't think I want to do that. I think that's going to be a little vague. I'll use that for another thing though. Here. There we go. You know, I don't think we need that. I think that's a duplicate dimension. I think it's safe to assume that if you see that the holes here are 25 millimeters away from this edge and 10 millimeters away from that edge, you should be okay. You should be able to assume that that's the dimensions for both these holes for locating them. What about hole diameter? I made all these holes 10 millimeters, so this is where I can say that's a typical dimension. So I'm going to actually dimension this hole right here. Click on that. 10 millimeters diameter, and I want to write down typical, which is typically abbreviated as tip, like TYP, period. There. That means it's a typical dimension. Or, instead of doing that, you could just make a note here in text. It says all holes 10 millimeters diameter. That's completely acceptable. Another thing that could be helpful too, so you know like what units we're in, because it doesn't exactly tell you down here. You could also say that all measurements in millimeters. So you can do that too. You can add notes to your drawings to better convey what they're about. Alright, so let's dimension these holes here. That way we know how to locate them, just like up above. Just locate them. You can get the... Here I think it's going to be easier to get the spacing between centers, just to convey that. Also do centers here too, but I think I'm going to do it like that. And I think that does it for dimensioning this drawing. Let's see if we have everything figured out here. So we can locate these two holes here. We know the diameter of all the holes. We know how big this side is here. There, yeah. We also know how big this side is because you can see that it's 50 millimeters all across. So that view's good. We know that's 50 millimeters tall, it's 10 millimeters thick. We know what the radius of this fillet is. We know it's 60 millimeters long. And then over here we can locate our holes as well. They're 10 millimeters from this edge, at least the top ones. The side ones are 10 millimeters from that edge, and these bottom ones are 20 millimeters from the top ones. So that does it for dimensions. Now here's another thing I want to bring some attention to is the title block. There is a way to make your own custom title blocks. I have not messed with it myself. I just usually do default ones. But you can see it's automatically populated with some information. But but you can see here that you can see that you can highlight it and click on it. You can change who approved it. You can do the date, which today is the 1st of November. You can edit all these attributes, that have the placeholders here. Just like that. Code. What code? Yeah, we're not following a code here. It's not like we're dealing with any mechanical code or whatever. But if you are, you can put it there. Drawing number, let's call it drawing number 1. Revision 0. How much does, I'm assuming this is referring to the weight of the actual part. That's how I've always treated it. I don't think it means like drawing weight as in like the thickness of whatever. Thickness of what your ink is, I guess. How you'd say it. Now I'm just showing you that you could what you can do here. Going into the future. Yeah. November 1st, November 2nd. Yeah, there's some weirdness there. That's okay. That's what it's about. This black here, it's usually for like an engineering staff. Engineering stamp. So if you have like a licensed professional engineer who's supposed to check the drawing, or I mean that's the thing with licensed engineers. They're licensed by the state, some government, so they have authority to tell you that whatever's with this drawing is going to work to its specification, and there's nothing wrong with it. It carries a lot of weight. I considered getting a PE license myself, but in my current line of work, that's not going to happen. But you know, it's not for everyone. But if you choose to go that route, I highly encourage it. But that's what this blank is for anyway. So now that we're done with the properties here, just click Finish Properties, and there we go. That's our drawing right there, all dimensioned and everything, so you know how to make this bracket. Yeah, so you can take it to a shop. You know, someone will know how to build this thing. Now, yeah, that's right. You want to take it to a shop, of course. You know, you can. Your first instinct would be, hey, let's print it, let's export it to PDF or DWG or whatever. But you see this sign here, this plus, that's a paywall function. You have to pay for it. Well, guess what? You actually don't have to worry about paying for it. I'm going to save this first. What you can do is you can go up here to File, you can go to Print, and you can just print to PDF. And whatever sheets you want and that sort of thing, and click the print button, and it will save this drawing to your computer as a PDF. So yeah, you don't even have to mess with this. You can just print to PDF, print to your printer. So you can do that. So that's how you can get away. That's how you can get around with that paywall. I hope. You know, that doesn't change. Otherwise, I'll be going to another CAD product. So that's how you could make these drawings something you can share. You know, instead of just this or taking screenshots. I mean, you can certainly do that too. Take a screenshot of this and print it. But I find it easier to just print a PDF, and you can do whatever you want with it. So that's how you do drawings in Fusion 360. You know, just another step toward taking your idea and making it into a reality. So I almost forgot to mention, typically the isometric view up here isn't showing. It doesn't usually show these hidden lines. So there's actually a way to change it so that it's more of a solid representation of the part. So in order to do that, you just click on it, right click, and go over here to Edit View. And that is where you can change the style of the drawing. So right now it's set to, let's see here, from parent. You can change it to just visible edges, visible and hidden edges, which is the same as from parent because the parent is the same way. I think that's the parent view right there. You can change it to shaded, so that looks just like it does in your model space, you know, based on whatever material you have selected for it. And shaded with hidden edges. So it's like that. You can, you know, shaded, and you can see like where the holes go through and stuff. So I prefer just the shaded part. That way you have a good idea of what it actually looks like. You could also do just a line drawing of the part too. I'm going to leave it at shaded. And then click close. And now it's all done. So that's how you can change that view to whatever. I guess if you really wanted to as well, you could change the other views to be like that too, but I've not really done that. It's something you can do. Thank you for watching this video. If you liked it, please be sure to click the like and subscribe buttons below. Also, post any questions you have in the comments and I may answer them in another video. And remember, anyone who stops learning is old, whether at 20 or 80. Anyone who keeps learning stays young. So keep learning, keep designing, keep making, and be proud of your work.